Dear students, in this video we'll see classical probability. What is classical probability? Classical probability is a probability calculated for an experiment in which each outcome is assumed to be equally likely. The probability of an event in such an experiment can be calculated by using this rule. What is this rule? That is P of E, that is probability of the event E is equal to number of outcomes in the event E divided by number of outcomes in S. This S is nothing but sample space, that is denoted by omega or S. This E is nothing but an event. Now we can see few examples to understand this rule in a better way. Now you see the first example. When flipping a fair coin, the two possible outcomes, heads and tails, are equally likely. So P of heads is equal to P of tails is equal to 1 over 2. Here we do flipping a fair coin. We know that for a coin we have two sides. One side is H. This side, suppose we say that H. This side, suppose we say that T. This is head, this is tail. Now what is S? S means sample space. What is sample space? That is total number of outcomes in an experiment is called sample space. That is, here when we flip a fair coin, only two possibilities we have. Either we will get head or tail, that is H or T. The total outcomes is 2. That's why I write n of S. Number of outcomes of a sample space is equal to 2. Now what is this? This is P of H is equal to 1 over 2. How we are getting this? Probability of head, that is here, probability of head. Here this probability of head is equal to 1. 1 means here the favorable event H appears in the sample space only one time, that is 1 divided by total number of outcomes, that is 2. That's why here from n of S I am writing 2, that is P of H is equal to 1 over 2, that is here probability of heads 1 over 2. Similarly we can write probability of tail is equal to 1 over 2 because tail appears in sample space only one time, so 1 divided by total number of outcomes in a sample space 2, that is 2. That's why P of 2 is equal to 1 over 2. That's why we are writing here P of tail is equal to 1 over 2. Now we will see the second example. That is, when rolling a fair die, each possible outcome from 1 to 6 is equally likely with probability 1 over 6. Now you know that, I think you know that what is a die. That is a cube having 6 faces with marked 1 dot, 2 dot. Similarly in 6 faces 6 dots starts from 1. Now you see in this face 2 dots, in this face 3 dots, in this face 6 dots. In the remaining faces we have 1 dot, 4 dot and 5 dot. This is called cube. Now we will write the sample space of rolling a fair die. Now here we know that 6 faces with 6 different numbers, dots here representing numbers 1 to 6. Now so first phase 1, 2, 3, 4, 5, 6. So we have 6 different numbers in 6 phases in a fair die. So these 6 values are total possible outcomes of a experiment. So what is S? That is 1, 2, 3, 4, 5, 6. Here n of S, total number of outcomes is 6. Total is 6. Okay. Now how we find the probability of 1 is equal to, how we find the probability of 1? Here the favorable event is 1. So now this 1 appears here only one time. So 1 divided by 2. Similarly, what is the probability of 2? Sorry, not here 2, 6. Probability of 1 is equal to 1 over 6 because 1 appears one time in the sample space. So 1 divided by how many total elements in the sample space? 6. That's why we have tried here 6. So 1 probability of 1 is equal to 1 over 6. Similarly, you can find probability of 2 is equal to 1 over 6 because this is n of s 6 from here, and this number 2 appears in the sample space only one time, that is 1 divided by 6. Similarly, if you find the probability of 3, probability of 3, probability of 4, probability of 5, probability of 6, all will be equal to 1 over 6. That's it. Now we will see another example. You see example 1. Consider the experiment of flipping 2 coins or a coin 2 times. I have 2 coins. I am throwing 2 coins. I am flipping 2 coins. So what are the possible outcomes? What are all possible outcomes when flipping 2 coins? When flipping 2 coins. Now you see here. In first coin, I get head. The same time, second coin also I find heads. Okay. So now this 2 heads together is one outcome. That is here. When I toss 2 coins, I can find head. That is one outcome. Second possibility is in first coin I can find head, second coin I can find tail. This outcome is head, tail. Second possibility. Third possibility is tail and head. In the first coin I find tail, second coin I find head. That is the third possibility, third outcome. In the fourth possibility, I find in the first coin tail, second coin also tail. That is fourth possibility. Now, what are all the total possibilities are here? Head, tail, head, tail. This is called sample space. Now, you see, first question, write out the elements of omega. Now, what is omega? Omega is nothing but sample space. Now, you see, omega is equal to write all possible outcomes of this particular experiment. That is H, T, T. Now, what is the second question? Calculate the number of outcomes in omega. Now, you see, these 2 heads together is one outcome. So head is 1, 2, 3, 4. So now here 4. So that's why n of omega is 4. Now see the third question. Calculate the probability of 2 tails. This is my favorable event. Now you see here, even A is getting 2 tails because here I need 2 tails. So now you see in the first outcome H, no tail. Second outcome HT, only one tail, but I need 2 tails. So no, here no, but here I have 2 tails. So now this is my favorable event. So now A is equal to TT. Now here the 2 tails together one outcome. So now how many outcomes in the event A? That is 1. So probability of event A is equal to this 1 divided by the total number of outcomes in a sample space, that is 4. So I am writing here 4. That is probability of A, 1 divided by 4. Now what is the fourth question? Calculate the probability of 1 head. Now you see my favorable event is 1 head. Now you see that is called B, event B getting 1 head. Now you see here 2 heads, but I want only 1 head. Here yes, 1 head. Here yes, 1 head. So now I can write this and this in my favorable event, that is HT and TH. So this is one outcome, this is one outcome. So number of outcomes 2 in the favorable event. So n of B is equal to 2. Now what is probability of B? This number is divided by the n of omega, the total number of elements of sample space. That is 2 divided by 4 is equal to 1 over 2. That's it. We'll see another example. See example 2. Consider the experiment rolling 2 dice. Now here we have 2 dice. we throw 2 dice at the same time. Now, what are the possible outcomes for the sample space? Now, you see, in the first die, I get 1. Second die, green color, I get 1. First die, 1. Second die, 2. Similarly, see here, first die 4, second die 4. First die 4, second die 5. These are all possible outcomes of when I throw 2 dice. 2 dice. This is the experiment. Now consider the experiment rolling 2 dice. So now these all possible dates are numbered here. You see here in this table 1 1. This is first die face value 1, second die face value 1, first die face value 1, second die face value 2. You see this first die face value 2, second die face value 3. Similarly, I can form this table. This is all possible outcomes when I throw 2 dice. Okay. Now, what is the first question? Sample space. Find sample space. Now, that is here. S is equal to write all possible outcomes when I throw 2 dice. That is called sample space. Yes. Now you count 1, 2, 3, 4, 5, 6. So here 1, 2, 3, 4, 5, 6 rows. So total is 36 possible outcome. This is one outcome. This is one outcome. This is one outcome. So total 36 outcomes. Now calculate the probability of rolling 7. In a die we have the number 1 to 6 only. So how we will get 7? You sum the face values of 2 dice. So now you see in the sample space 1 6 is 7, 2 5 is 7, 3 4 is 7, 4 3 you add 7, 5 2 you add 7, 6 1 you add 7. These all 6 outcomes will give sum 7. So that is your even. That is the second question. So second question B, your even, favorable even is equal to, you list all these outcomes, whatever values give sum 7. So 1 6 starts from 1 6 and stop it 6 1. So how many values? 1 2 3 4 5 6. So now n of a is 6. What is the probability of a? That is n of a 6 divided by the total outcomes, 36. So your answer is 1 by 6. This is the probability of sum 7. Now what is the third question? Probability of first die is odd. Okay. Now you see this is even B. Now you see in the first row here, what is the first value in the first die? 1. That is odd. Here 1 odd. Here 1 odd. Here 1 odd. So the first row, you'll see the first die face value is odd. Here that is a question. First die is odd. So here first die is odd. First die odd. First die odd. So now here first die is odd. First die is odd. So row 1, row 3, row 5. So these 3 rows giving this answer. First die is odd. So you list here the even B is equal to row 1 you copy, row 3, row 5. Here all values starts, the first die value is 1 here in the first row. Here you see 3. This is also odd. The first die value is odd. 3 is odd. So now here 5 is odd. So here fifth row value you copy from here, fifth row value. So now total outcomes is 18 in this even B. So this is first die is odd. So total 18. So what is the probability of B is equal to this 18 divided by this 36. That is 1 by 2. That's it. Thank you.